see a few familiar faces joining. Nadezhda, Natalia, Valerie, hello. And oh my God, there is Emir, a blast from the recent past. Hi, Emir. Perfect. Let's begin. Today's meeting is more of an interactive meeting with team of Custom.MT to kind of present to you our view on evolving translation quality pipelines, and also to get you familiar with what we're doing this year. We hosted the conference 2 weeks ago. I think we had 0 presentations from Custom.MT. Everything was coming from the program committee, from the speakers. This is the webinar where we share what we've been doing all year. And strap in, we're going to have like a 35, 40 minutes presentation, remind you about custom machine translation and the advances today, and give you an overview of the building blocks of translation quality. With this, let's kick off already. So, excellent. Perfect. Elena, you have the screen, right? You have the slides. Let's go. One of the important trends, let's skip that we are now 5.5. One of the most important trends of the last year is that everybody started using ChatGPT and Anthropic. By everybody, I mean that it went from 300 million people to more than 1 billion people. Most of the people are using are on ChatGPT. Most of the corporations spending their monies with Anthropic. This is a big trend. If you go in a train, on a bus, any waiting room, you'll see people chatting with the online chat assistants about their relationships, about what to wear, what to cook, and sometimes they're using them to translate, which means fewer and fewer people need outside help to translate. They are so familiar with the web interface, giving them everything they want, that it is very natural to drop a document that you need translated in PDF, in any kind of format, and get it rendered in your language immediately. And this kind of self-service means that there's less need for centralized localization and more decentralized localization, where people are just using a favorite app and getting the result they want. And if not, then they come to localization in a business setting and say, hey, can you check this out? I've translated this with ChatGPT. Is it good? So this is a massive trend with the tokens being spent by the users of GenAI, and less going into the localization proper. For the localization teams, I've recently been to Localworld in Dublin, and I've seen that almost everybody are facing the same challenges. If AI can do it, then why do we need human review? Let's reduce the amount of money going into human review. Let's increase the volume that we can cover with human review. Only check what is important. If you have support documentation, if you have something just for understanding, maybe not the most important language on the website, more and more often it will be just AI translated. Recently, I've been to an architecture festival, and all the guide information at this festival has been AI translated, and it says translation by GPT-4. Like, that's the offer of translation. This is what is happening. With the convenience that these apps bring, the risks of mistranslation are getting less and less of a problem, right? So in the past, when it just appeared, we were worried about our privacy, we were worried about hallucinations, less and less so. So this trend will continue to pick up. And in the business or the enterprise setting, we've seen people use Amazon tools. We've seen tools like N8N being implemented in order to create this kind of multi-step agentic workflow where you have one LLM checking, another one translating, the third one kind of rewriting. And a developer can quickly build up this agentic workflow now with readily available tools, not just for translation, but any kind of need. So a lot of this GenAI translation happening all around us. less for professional localization. What do you do in a scenario like this? I've prepared a picture that kind of tells the story of 1,000 words. Elena, please. Everybody's cycling, and you have a localization team. All around you, the business stakeholders are using Gen AI tools to get the translations. What do? You just need to cycle better and faster. And there's been the story of the Sky team from Great Britain who didn't win any Tour de France for many years until they got a legendary trainer, the head of the team, who introduced a policy of incremental improvements, 1% in everything. So he improved how people on a team sleep, what kind of pillow they use, what is the aerodynamic capability of the bike, what kind of tires they use. So small improvements in everything. And essentially that led to the team of Britain winning Tour de France for multiple successive years. So they really excelled. And this is, I think, what we should do now as people on localization. We should build better pipelines, outrun the IT teams, offer something to the users of Gen AI, which means that your quality, your offering is better than what they can get. And by this, I mean a kind of an automated pipeline for translation, which includes a lot of components, making it better than the one used by a normal person through a web interface of a Gen AI tool. Let's go on. This you already know. So this is the plan of a typical agentic workflow from the past. You would have one LLM translating, another one editing, the third one reviewing or doing quality estimation using an older term. And if the reviewer says it's good, then it goes immediately to publishing, skipping the human. You trust the AI reviewer to an extent. In November last year, we had a benchmark made about how much you can trust it and how much you can save. So this data is available. If the reviewer says no, quality is not good enough, then it goes through a system of checks and a system of corrections to make sure it becomes publication worthy. Now, what can we do with this to improve? Elena, let's go through the next one, and you can click a few times because I have this kind of list going one by one. So this pipeline is getting improvements. What kind of improvements I think are important? Context. If you take a sentence outside the context, just one out of the document, it doesn't follow the gender of the person. It doesn't follow what's been said before or after. If it's presented the way like it's presented in capitals, segment by segment, the quality is lower. If there is context like adjacent sentences, or if there is a screenshot or a video, that's already much more informed kind of AI translation. Second, source quality of the data. If you're given it examples which are good quality from translation memory, from terminology, then you're feeding the LLM much better kind of previous translation examples closer to your style. It can adapt to you. Terminology. Terminology has been implemented in the translation step. Now, our system and similar systems, they use RAG or retrieval augmented generation technique to inject terminology into the AI translators and AI editors. But what about the reviewers? Do the reviewers also know your terminology? So this is the next step for the AI reviewer to understand when terminology is missing. Next is a new technique which is becoming more popular called LLM, not as a judge, but LLM as a jury, when you use not one AI judge or AI reviewer, but three, and they vote whether the translation is good or not. This has been proven to have a better correlation with human judgment and a better correlation of judgment of a group of humans. Like if you're evaluating a translation, one person would say it's good, another person would say not so good, the third might say it's completely missing the point. Subjectivity is still a factor. with LLMs, if a few of them vote, you get closer to a translation accepted by more humans. So this is a potential improvement in the pipeline. Then guardrails, right? If you apply all the steps with LLMs and you have no deterministic checks, then sometimes hallucinations get through because still out of 100, maybe 1, 2, 3 sentences would time out or hallucinate. So you need some kind of a mechanism which does not depend on this random seed character of an LLM. So you want to have as many as possible, and we've come up with almost 50 different checks that a system can perform on an LLM translation. And finally, the speed. If you have multi-stage workflows like this in your orchestrator, then it might take hours to run a document. Like if you have 10 pages and you have 5 or 6 prompts and you go sentence by sentence, it might run into hours. So no system can wait for that long. You have to do it in a way translators did it in the past, execute one operation to the second operation. So it cannot be done instantaneously like machine translation does it. It's very similar to a manual process and it's asynchronous kind of scenario. So there's number of different components, the quality that constitute a quality pipeline, how it's applied in the scenario, whether it's a CATO, whether it's a document translation portal, whether it's a kind of a reviewer which goes after machine translation checks, depends on the user scenario. We'll go through some of the things that we've already deployed today in production at Custom.MT, and hopefully you'll have questions and support us with your cases and your anecdotes from the field as we go along. This concludes my part. Elena, perhaps you could take it from here and show us the first thing that we have on the menu today. Thank you.
Sure. So I will jump in at this point. What we thought of doing is going in, as Konstantin was saying, a bit more into details about things that are already in production in Custom.MT console that I will show you a bit later, but also on projects that we have run that have either brought us to the point where we are technology wise or has made use of such technologies that we have deployed over the years. So the first thing that we have already mentioned is so-called QE, quality estimation, which basically is a model judging the translation, right, without a human reference to say whether it's good or not. And this is the one that we have tested as a community benchmark at the beginning of this year, last year, I don't remember, either this year or at the end of last year, that have produced the results that Daria has shared in the chat. So if you want to take a look at that, you have the link there. Quality estimation has been in the field for a while, but with LLMs, it has now reached new sort of new heights and new possibilities, because now the model is not just a structured and fixed model that you can use, but there's also the possibility to prompt, and therefore to have the possibility to customize also the judgment by the LLM. What we did in this case, it was a quality estimation project for a subtitling client of ours, and the interesting thing in this case was to evaluate the correlation between the machine judgments and the human judgment, which means so if the LLM says that this is a good translation, is it really a good translation? So would a human agree with the LLM, one or more humans in this case? Would they agree on with the LLM, or would they judge it as a bad translation? We had two linguists, so two humans in this case, judge the evaluations, so the translations of two models for 12 languages. So it was quite a broad spectrum in this case for subtitling, as we said. We had some quality estimation, so quality pipeline customization. So we customized the prompt specifically for subtitling. We decided what models to be using some techniques that Sasha will talk about later, Alexandra will talk about later. And then we had a human QE. So we had one linguist say, is this a good or a bad translation? Right? So purely good or bad. And the human validation on the not human QE, so LLM QE. We used as LLM as a jury, as Constantine was mentioning. So more, we had, if I remember correctly, Gemini, one of the Claudes, some of the GPTs. They all gave their own scores, and in the end, the agreement factor was the one that was evaluated by the humans. With a simplified MQM structure. So they also said, okay, this is wrong because, and finally a binary blind evaluation. So is this good or not? And interestingly, the correlation between humans and QE in this case, it's pretty high. So it's between 73% and 97%. So it's pretty high up. It means that humans agreed with the machine, with the evaluation by the machine, with the estimation in this case by the machine, at least the 73 in 73% of the cases. We had quite an extensive data sets for this kind of evaluation, considering that it took quite a while for the human to go through 800 segments per language. And we had, again, up to, on average, an 89%, yes, human QE correlation. How did this then
Elena, this is very close to what humans agree,
agree
the
with each
agreement of
other?
humans between each
No,
other, right?
no, humans agree much less than this. Usually humans don't agree with each other.
Machines are syncopaths, right? They make us agree.
Yes, they can explain, they can be very, I don't know, they are very good at convincing us that they are right, apparently. Human agreement has always been a problem in this kind of evaluations. It stays a problem. Humans don't agree with each other. Humans don't agree with themselves as well. So I don't know if you have ever tried translating yourselves. You translate one sentence one day and it's perfect. Then you go back a few days later when the whole text is done, you read it and say, did I write this? When? Why? So that happens. Um, so as I was saying, how did this translate into what we have? So our product. Let's try to show you. So let's move this. I hope you are still seeing the screen. I am not seeing you anymore, so I don't know. But so for those of you who has not seen the console, this is Custom.MT console. It's an aggregation tool. So what you can see here, you have a list of different providers that can be used for different steps in the quality pipeline. You have models that can only be used for translation, like the neuro machine translation or style. Some that can also be used for automatic post editing. Some of them can be used for QE, as we are saying, and some others can be used also for terminology implementation that we'll discuss in a second. So how do we use then quality estimation? I will show you in Trados. This is also available in MemoQ with some limitations, but we are discussing with them to make it better and better, and coming up in other tools next. What you do in Custom.MT console is you create translation pipelines. So this is an orchestration tool. So you create your own translation workflow. I have created one already because demos, you never know. So in this case, my workflow for translation, for the translation that I will show you in Trados, only includes a translation step done by an LLM, GPT, and I will show you why in a second, and a QE step. The QE step, in this case with Anthropic, you have different models you can use. I chose Anthropic just because it was the first one in line. You have a threshold that you can select, and the threshold will tell the Trados basically, whether a segment is good or bad. So you set a threshold. Below that threshold, so this value, anything that gets scored below this value is considered bad. Anything that is scored more than that value is considered good. On top of it, once the segment has been scored as good, you can also confirm it automatically and lock it automatically. I will show you in Trados in a second. But first, let me explain why I use an LLM for translation, because I had to use a simple text for a demo because we couldn't in half an hour that I have to talk go through a lot of different tools and also stop to look for mistakes. So what I actually did is I automatically generated mistake by asking what this OpenAI GPT-4 to translate wrongly. So I said, translate the opposite of any verb that you find in the source text. So the scores should vary a bit. What I got is basically this in Trados. So you have your project in Trados. For hope you are kind of familiar with this, but this is more or less the same in every cat tool. So you have your project, you have your file, and when you open the file, you can see that the first segment is already locked and the other ones aren't. So when you click on a segment, you can see the TQE scores, so the quality estimation scores. This is a 15. Since it's lower than our threshold, which is 80, then the segment is left as a draft, as a translation, a machine translation draft. In this case, this did not have verbs that could be translated as the opposite, so it was a very good score that got automatically locked and automatically confirmed. You can also imagine you have kind of a more varied alternation between locked good segments and bad segments. You can also filter them. So when you apply the filter for poor, everything that is already locked can be left off.
Elena,
This
did you
can
experiment with the prompts to see what type of prompting or what kind of suggestions help make the quality estimation more accurate?
we have experimented that. So the let me go back to presenting the uh, the, the the data that you saw before about the project that we already had were done on after the experimentation that you were mentioning. So sorry, let me go back. So this data is already after this experimenting. We have the few runs, I think 4 or 5 runs with different prompts. We got the best one and then run the experiment with humans.
Any suggestion? What makes a quality estimation prompt good?
Um, the same that it would make it good for humans. So tell the LLM what they are supposed to be doing. If you can give them very concise but very precise indication of what you think it's good and what you think it's bad, right? In this case, it was, well, for subtitling, it was very interesting because one of the things that we found LLMs are very bad at is counting. So for subtitling, you have to have 42 character per line, and they could not count it, right? So they would give good estimation, but then you count the character and say, look, Claude, this is not 42 characters. Oh, you are right. This is not 42 characters. So why didn't you point it out before? Uh, Surprisingly, Claude, and not even the last famous Fable 5, but the version before that got better at counting. So we are getting there. But yes, so be very precise on the language, be very precise on the structure of the document and of the content you would really like to have evaluated,
Excellent.
and give context.
Let's push ahead a little faster so that we make it within 45 minutes.
Yes,
So I guess this concludes the quality estimation block.
this does. So let's move on. Second step would be TM cleaning,
Let's
which
do
is
the very quick expose on TMX cleaning and terminology and spend a little bit more time on evaluations today. I'm interested in how our ladies and gentlemen in the audience today, how you respond to the evaluation progress.
Sure. So this is kind of well-known material, let's say. So translation management, translation memory management. Good translation memory makes good translations. So it is still true that garbage in, garbage out, as people were saying. So what you basically have is that once your translation memory are cleaned, they can be used for better context retrieval, better translation, better machine translation training in case it's interesting, etc. So one interesting case that we have, it was about translation management, translation memory cleaning. It was a um, pretty big project actually. So we had about 28,000 segments to be cleaned that we cleaned first automatically. So our approach was first filtering out. So the usual cases, with the duplicates, empty segments, everything that can be done automatically. And we cleaned the first batch. Second part would be LLM flagging. So the LLM flagging is particular. So the LLM says, okay, there's a mistake here, and then it tries to fix it. What happens in that case is that you don't just remove the segments altogether, but you try to save it. So you have some of the original machine translation memory. As you can see, these are just two examples, French and Swedish. There's some of the original that is already saved. It's already good as it is. And as you can see here in the original high quality. And then you have a good bunch of segments that were saved by the LLMs and checked by the humans to validate the saving by the LLMs. And then there's a bunch of segments that could not be saved or should not be saved because they are useless, and those got completely removed. So it's duplicate, empty segments, and space inconsistency some got fixed and some broke the segments altogether. Tags
I
not
think it's
mentioned.
important to say here, Elena, that we used to do this with smaller models and more deterministic checks, and now we are gravitating towards using LLMs because the result is better.
Yeah, yeah. So at the beginning, it was a human sitting and reading and probably crying with translation memories, and then it was smaller models, not crying anymore, maybe, or maybe crying and we couldn't
The
understand.
engineers were crying with smaller models.
Oh yes, the
Uh,
engineers were totally crying, but I think the engineers might still be crying a bit with the bigger model, but the human at the end of the line, so that the
I can see
linguists are
the
not
engineer who
crying
was
anymore.
crying.
Yes, there is one engineer that has been crying a lot, but the linguists are not crying anymore, surprisingly so. So with the bigger models, the final outcome that the linguist needs to check is actually better. And the final for me at least, before we go into the overall
Evals.
pipeline evaluation pipeline, would be term extraction. So term extraction is basically glossary creation, right? So the interesting thing about terminology is that sometimes it gets underestimated by linguistic um, by the linguistic sector, let's say. So they have translation memory. Why do they need terminology, right? Glossaries. Actually, we did try, and what we saw with a case study that we had was this was a test that we ran to understand whether the client really needed to have these glossaries. And what we found is that the glossary implementation during the translation actually creates a better translation, which means that the post-editing effort decreases, delivery time is faster, and therefore costs are reduced. The results of this test, this was a smaller test, but it was very promising. So the client itself decided to then expand the terminology implementation throughout their topics, let's say. Um, and at the beginning, again, humans were crying. So we went to humans to say, okay, this translation memory, please extract terms. And humans said, if I really need to, okay, how much are you going to pay me? Then we went again to smaller models. Hey, extract, and weird things happened that we will not recollect right now, but they did happen. And now with bigger models, this actually works pretty well. In particular, let's see if I can show you the video right now so we can move a bit faster than with a live demo. We have a new tool that is this terminology extraction tool. In this case, what you do is basically you create a small project with LLMs. And that's me not knowing how to write things, but you select the languages, right? So you will extract from the source language, select the domain so the LLM knows what you are extracting and it will not extract, again, weird things like the smaller model. You insert a text or a document that you want to extract it for, select the model that you want to use, and start generating. You get the first bunch of extraction, 53 in this case, were extracted by this, I don't know, text about
Cool.
AI.
Cool. Yeah.
Yes,
Model.
first thing that you will do is run these filters so they remove the duplicates, remove everything that is not in context. In this case, there wasn't many, but 50 were left. Out of these 50 terms, you can now generate the translation that will actually create your bilingual glossary in the end. Once you have everything, you can what am I doing right now? You can approve or modify. You can reject, so therefore delete the term if it's still not consistent with what you want. Approve everything, and this will create a new glossary that you can use during translation in the pipeline that we have seen before.
I think it's important to say here that what we're trying to achieve with AI terminology extraction is that this is a regular process and that it is synchronized across applications. For example, an extraction of terminology done on a daily or a weekly basis. New terminology flows both into the cat tool, such as MemoQ, where we have the first synchronization integration developed, Trados and online TMS. So both human systems and models, RAG systems for LLMs received new terminology, and then essentially probably what we need to do is once it's all working on a regular basis, hide it under the hood so that it becomes a background process.
Yeah. At the moment, this can be run even for every project. Basically, you just upload the source file and create your approved term list that then can be used by the machine translation during the translation, but also by the post editor during the checks. And with this, I will just leave the floor to Alexandra, please.
Sasha, good luck.
Thank you. Greetings again to everyone. Thank you for being here with us today. So as Elena has anticipated, our team has dedicated a lot of effort to developing a scalable quality estimation tool. Now, in this landscape, when new state-of-art models are being released almost every week, we can see on the chart by a AI release tracker that during the second quarter of this year, 22 state-of-art models were released. It's the need to have a reproducible tool that delivers repeatable and scalable results is tangible.
I think it's important to say here that not only new models get released, but old models get phased out. At the moment, you're lucky if you're setting up a workflow with GPT, I don't know, let's say 4 or 5, and it stays for a year. More often than not, an older model would be phased out and you upgrade to the next one and you need to see how it performs.
Thank you. Elena, please change. Could you change, please? What's the core of our approach to evaluate the models which get deprecated or phased out? Basically, it is an end-to-end process that answers three fundamental questions. Which model is the best? What are error patterns and why they might occur? And how does it perform for our specific content, specific audience, and the market? To answer these questions, we suggest breaking this workflow down into three simple steps. First of them would be data preparation. It means that either existing translations can be uploaded, or the user can translate their data using Custom.MT workflows. Basically, that means that not only sheer models can be evaluated, but whole workflows, including glossaries, what Elena was showing a moment ago with APE and pre-editing, and even experimented with prompts to be able to evaluate them at scale. And also, there's an option to enrich your data with traps from benchmark pool, or create a dedicated data set, challenge data set, golden set containing these traps for your relevant need or your audience. The second step would be going beyond numbers. It means drilling into segments with errors and seeing the patterns, reading with eyeballing them, and identifying the patterns that certain models or certain providers tend to make. The third step, the crown to all of this, would be routing errors according to specific guidelines to human review, which would eventually save a lot of time and effort. Elena, please change. Thank you so much. So, as Elena was saying a moment ago, garbage in, garbage out. So the foundation of any robust system, our quality estimation system in particular, would be data. Our approach would suggest utilizing what we might call challenge data set. This would be certain stress tests for neural networks. These are specifically curated, compiled data sets with difficult segments, so that allow us to test models' resilience and accuracy in scenarios where simple engines would struggle. As you might see in this slide, the first segment contains already a gender trap, because in Spanish it was rendered CEO, in English was rendered in Spanish as el CEO, which might not be considered inclusive. Other traps would include structural traps, such as tag reservation, dates, addresses, and other kinds of traps. Change, please. So once we have the data, we can move to three modes, three regimes of side-to-side comparison. This is where we might see that different engines handle the exact same text in real time. By comparing them directly, we can quickly filter out the underperformance and focus our attention on the models that actually deliver the quality we require for our audience. For instance, in this case, we might see that the LARA model is underperforming in safety and compliance MQM dimension, while DeepL is doing the best job in this. Change, please.
I like this kind of hexagon structure, which points to different types of evaluations, right? You have MQM typology here: accuracy, fluency, terminology, design. So how do you pick one which is the best? If you have so many criteria, what's the guidance for the user how to pick the best?
The guidance for the user is a built-in embedded system, part of system that allows the user to set priorities. For instance, for one user, for some medical content app, terminology and accuracy would be the best, would be the best dimension they want to have, the most relevant dimension they want to have in their translation well covered. So the scores you can see below the donuts, 94, 93, 90, 91 are the scores that are calculated based on the importance, on the weighted importance of the criteria one selects, so the score already guides you to the engine that respects your choice according to the priorities you set in the evaluation hub we are developing right now. Yeah, that would
Got
be
it.
the answer.
Thanks.
Thank you. Please change. So what makes the system truly multidimensional is that we can use several modes to evaluate and perform this automatic quality pipeline. On the left, you see that we can have a breakdown to languages, to different languages on the same content. For instance, we have here German, French, and Spanish, and as we might see, the Spanish is underperforming in safety, for instance, because it has more errors. This is achieved by a combination of LLM juries, 3 in this case, and deterministic checks, which which all of them are concentrated under the umbrella of MQM network. For instance, we have numbers and units evaluated by a deterministic script, Python script in this case, and they go under the umbrella of accuracy. At the same time, LLM jury, a panel of jurors, is evaluating at the same time accuracy, but from the other dimension, evaluating omissions, additions, and mistranslations. The third dimension we can evaluate is over time. As you might see in the second example, we have September models, June models, March models, January models. And we can have an idea what model is or what provider is getting degraded over time. And we chose to show this with automatic metrics to make the point that automatic metrics sometimes might be seen as obsolete indicators that do not tell you anything about terminology, gender, or safety concerns. Change, please. This is why we might have a solution that answers the question not only which engine is the best, but for what is the best. It can be one, of course, there is no one size fits all, but pragmatic checks that we include and judge persona integration that is, sorry for repetition, that judge persona is also been integrated into this tool might guide the user to the best translation that fits their market or their client needs, or might not be offensive to a certain kind of audience.
Right, so a marketing person would probably look at fluency, or a person who's working in regulated would look at model terminology and safety. Missed term in a drug use is much more harmful than a missed term in a marketing scenario.
True. I agree with that. I truly agree with that, and we might give you an example of that on this next slide. Please, Elena, change. Where we might see that the model exactly flagged so one of these cases, medical cases, which might be considered dangerous because the translation over the source might instigate the user to take some biological additive. So the jury flags that it has a pragmatic risk, a medical risk, and it goes to human review. And the human decides whether the wording is appropriate or whether the translation needs some kind of adjustment. So the goal of human review in this evaluation hub is to reduce the operational cost and time of human evaluators to decide whether the translation is apt for publication. And the guidelines, the rules defining which segments are being routed would be jury split or critical severity or major severity or edge cases when the models cannot decide whether this case is has to be treated as a median shift case or a pragmatic medical risk case, as we see on the screen.
All right, we're on a strike of time. We're about 3 minutes after the allotted time for presentations. Shall we wrap up here?
Yes, I think I'm done and ready to answer all the questions that might occur related to this topic.
So to summarize, this is Sasha, this is your new work. In the past, we've been selecting models by looking at blue scores and where there are rates, which are easy to calculate. And this is a next step where we can use human evaluation, LLM as a judge, LLM as a jury, and a combination of metrics to find the best model, not by one criteria, but by a number of criteria, and specifically by selecting which criteria are important for us. So to become a much stronger evaluation house internally, whether it's in a translation company or in an internal in-house localization team. That is probably all the content we have prepared for you today, ladies and gentlemen. Let's see if we have any interesting questions in the chat. Thank you for your attention. Let's have a look. Number one, is LLM jury always reliable? Sasha, Elena, do you have any numbers on hand?
I would say that LLM jury, LLM as a judge, is not always so reliable, and that is why 3 of them are being more and more introduced, more often introduced to evaluate the workflows. And sometimes such technique as a meta judge over the 3 judges is being used as well. According to the numbers, in the worst case scenario, counting the cases of jury splits, jury not agreeing with deterministic checks, and juries given different judges prescribed in different categories to errors, it's about 20% of the segments which were flagged as unreliable. So that would be the answer to your question, the numbers.
80%, juries, very close to humans. Right?
80%, yes. It's almost the same Elena was mentioning a moment ago. I had the same results in medical domain, which I was testing during this week.
Excellent. Let's look at the next question. Michael is asking, which models do you use for the LLM panel?
We have been experimenting with Gemini, with Claude, and with OpenAI. I would say that most of them were reliable, and sometimes I had issues with Gemini, which tended not always to return a valid response. But I think that this wasn't a major share of the cases, and in case it happens, the segment immediately goes to human review because we have a tie. In the worst case scenario, we have a tie, 1-1, one fail, one pass from the rest of the jury, and it's not reliable, so humans review this. But I repeat, that wasn't a very extended case.
Okay, well, Kirti Vashi is asking a question. How do you know which 20% is the problem? Kirti, always an agent provocateur. Perhaps you'd like to say something about this. Kirti, you worked with the same problem. Kirti? All right, let's answer the question then. How do we know which 20% is the problem?
We know 20% is the problem because I reviewed them manually, and there was a problem. Of course, this is the blueprint, and the prompts need to be adjusted. But according to what I saw, according to I saw the jury split was not so wrong. Humans might tell the same. So
it's very close to humans. Like, how do you know which segments are missed by humans? An excellent answer.
This is the same. And I reviewed the information. I reviewed the responses in German, Spanish, French, and this was basically very close tie situation between the languages. And I reviewed age cases in jury split and severity in formatting problems. So my response would be me as a jury over the jury.
I'm sorry, my question was meant to focus on like what happens when you have large volumes. Do you have to check them all? How do you know which part is wrong, which part is right?
I guess Kirti,
really
the answer is you build the system as well as you can, and you rely on statistical probabilities. You know that there's going to be a part which is wrong, and you accept the risk.
Or putting very strict deterministic filters on the answer. I mean, if the model is not sure, the confidence score is low, or we have contradictory results from deterministic checks and LLM jury. All of this are excellent cases for testing and for adjusting, for taking decisions whether the reply was reliable or not. Did I answer your question?
Yeah, you answered. Thank you.
Thank you, Kirti. It's a nice discussion.
Thank you for the
it's
question.
nice dialogue. All right, next question. Ibrahim is asking, I guess, Elena, this goes to you. During the TMX cleaning, what if you have inconsistencies, right? So you have one source, two different targets in two different scenarios or context. How does the LLM know which one to keep?
It doesn't, unless you tell them. So if it's a food repetition, one of them gets taken out. So that's pretty easy. Otherwise, there's two possibilities. So the first one is to simply flag the repetition as a doubt to the LLM. So this has the same source, different target. Humans, please check. Otherwise, you say it in the prompt, right? So for instance, you can give it terminology. So if in one of the two translation the terminology is wrong, the other one is correct. If the prompt says, for instance, convert, I don't know, euros into dollars, and one of those doesn't, then it simply skips. So it's either human review at that point or some indication of which one is right and which one is wrong.
Okay. Next question from Jill. For those models that can do quality estimation, do you do any training on them? Let me answer this one. Jill, in the past, when Custom.MT was founded, training and fine-tuning models was our bread and butter. That's all we did for a living. And since the advent of LLMs, this has completely disappeared. We fine-tuned OpenAI when the interface became available, but prompting and RAG completely replaced the need to fine-tune, at least within our organization. It just doesn't make sense to fine-tune these larger models because they change all the time, because RAG systems are kind of easily manageable. You don't have to update the fine-tunes and refine-tune unless you have an automated training pipeline tied to a specific customer and scenario. Fine-tuning doesn't happen with us any longer. Perhaps with other engineering houses, they still keep it. But we don't. We haven't fine-tuned an online system for a long time, only for a couple of on-prem scenarios when it was like analysis of cyber security stuff, this kind of scenario, which cannot go online for some reasons. Then we used a smaller model and it was fine-tuned to the domain. Otherwise, it's a couple of times per year max. Everything else is RAG and prompt adjustment. All right, I hope that helps. And there's one final question from Steven. Steven, long time no see. How are you doing? Glad to see that you joined us today. And Steven raises a very painful question of money. If you have 3 jurors and they all consume tokens and all of them are frontier LLMs, how do you keep cost under control? Do we have an answer, Elena, Sasha? How do we deal with this?
Well, for instance, I didn't count. I didn't make an analysis and a person versus LLM, but there are techniques that can reduce the cost. It's Batch API, Gemini, Claude, and OpenAI have these options which significantly reduce the cost for at least QE. So it might help, and caching some requests, some popular requests in projects might help as well. This is the major technique that would help to reduce this pain. However, the tool we are developing has this functionality that might guide the user how my tokens and money is being used on your project right now. So it might help.
If I
All
can
right.
answer,
Thank you very much. We have one question from Emir. Emir, since we're on friendly terms, you can just stay after the meeting and we'll answer it face to face. Everybody else, thank you very much for being a fantastic audience tonight. I really enjoyed it. It was interactive. Hopefully you learned something relevant today and it was good for you. Sasha, congratulations on your debut on stage with Custom.MT. Well done. And Elena, always a pleasure. With this,
as
I
always,
conclude the meeting today. We'll hang out off recording and say hi to old friends, of which I can see there are many in the room today. Thank you, and goodbye for the rest of us. So can we switch off the recording, Dasha? All right. I stopped the recording. Some people are still hanging out with us. How are you doing, guys? Emir, how are you? We're off the camera now. I hope we're not broadcasting anymore.
Hi, can
We
you hear
are.
me?
So give
I
me a
We
can
are
hear
second.
you.
broadcasting. Let's switch off the broadcast.
Yes, give me
Sorry,
one
Emir.
second.
All right, maybe we switch off this meeting and we jump into